Hi, Algebra 2 students. This is a video that goes along with your packet on Introduction to Function Operations and Composition. And I'm starting on like the third page or like the front of the second sheet of paper. This is problem number 4. And this is starting with this process of what we're calling function composition, whereby I'm saying what if g of 36 is the input or is the x value that I'm plugging into f, right? So the idea here is I'm first going to find what is g of 36. So I can do that off to the side. G of 36 is equal to plugging in 36 for the square root of x. And then I get the square root of 36 is 6. I'm always going to choose the positive answer here, not negative 6, because when we just evaluate a square root, we're always assuming the positive answer. So now I know that f of g of 36 is the same thing as f of this 6 I just found. So now all I need to do now is plug in 6 in for x in f of x. So if f of x is x minus 6, I'm going to replace this x with the 6 and get 6 minus 7. Sorry, x minus 7. So then I do 6 minus 7, and I get negative 1. Okay, so that's an example where I'm finding a specific value, and I get one number answer as my final answer. Okay, so now we're going to look at some examples where I'm given my information about the functions in a slightly different form. So here we have a mapping diagram or a table, but it works kind of the same way. So first let me see, what is g of 9? Well, when x is 9, this is my g function, right? When x is 9, y is negative 1. So the y is the same as g of x, right? So that means that this is your g of 9. So if g of 9 is negative 1, now I'm finding f of negative 1. Well, now I'm going to come over to my f function and say, here's, if this is x and this is f of x, or my output y, I'm saying when x is negative 1, y, or f of x, is negative 4. So now I know that f of g of 9 is equal to negative 4. Taking a look at number 8, if I start by finding g of negative 4, come over to the g table, I see when x is negative 4, y, or g of x, is 8. So I know g of negative 4 is 8. So then I'm finding f of 8. Again, I'm replacing that g of negative 4 with the value I see in the table. But if I come over to here and I look for where is f when x is 8, I don't see 8 as an option. It doesn't mean that it doesn't exist in this function, but at least from the information given, it cannot be determined. So I'm just going to write cannot be determined. And that's as far as I can go, because we don't really know what this is. Okay, in the next section, we're looking at a graph of f and a graph of g. So I'm looking, remember, this is my x-axis, so the idea would be I want to find the value in parentheses on the x-axis. So first starting with g of 2. If I go over to where 2 is on my x-axis, and then where is my function g? My function g is this kind of straight line segments. So if I trace down to the graph of g, I have the point right here, which is the point 2, negative 2. So what is g of 2? G of 2 is negative 2. So now I know I'm finding f of negative 2. So that means now I need to go to where x is negative 2, and I need to trace down to my graph of f of x, which is the quadratic, and I see there's a point here which is negative 2, comma, negative 4. So that's showing me that f of negative 2 is equal to negative 4. Okay, so now in this next part, we're actually looking at what's called, again, this is called function composition, when we're plugging in one function in for the x value in another. And now we're saying f of g of x. So instead of having a number for x, we just have the whole function g of x plugged in for x in f of x, okay? So that may kind of sound confusing to think about, but the idea would be like, if g of x is x squared, then what am I going to do? I'm going to take x squared and substitute it in here for where g of x was. So now I'm finding f of x squared. So what is f of x squared? Well, f of x was x plus 7. And then I'm replacing the x with an x squared. So instead of that x, I'm writing x squared in that spot. So this goes to this. And then I still have a plus 7. Now I am looking to see if I can simplify, but x squared plus 7 cannot be simplified. So essentially we know that f of g of x is equal to exactly x squared plus 7. And I have this new function. I'm going to leave this one for you guys to try to do on your own. Okay, and I'm going to move on to the next page. So on the very back, there's an introduction of a new notation. So it says the composition of a function g with a function f is written as g, and then we have this like new operation, which is an open circle. So the way we would say this out loud is g composed with f. So I would write g, I would say g composed with f. And that is exactly what this is meaning. And how are we defining it? We're defining g composed with f of x to mean g of f of x. If we plug in f of x for x in the g of x equation. So that's kind of a mouthful, but let's see how it looks in practice. It's not very different than what we were just doing on the previous page. Okay, so in number 14 it says f composed with g of 3. So notice the order here is different, so that means that f is the outside function and g is the function on the inside. So I would write this as f of g of 3. And now it turns into a problem like we were doing on the previous page. So I can kind of work out what is g of 3. G of 3 means plugging in 3 for g of x, so I'd do 3 times 3 minus 2, so I get 7. And now I'm taking that 7 and plugging it in for g of 3, because it is equal to g of 3. So then I would get f of 7, and now I'm plugging 7 in for x. So I do 2 times 7 squared, and 7 squared is 49. 49 times 2 is 98, so we know that f of g of 3 is equal to 98. I'm going to do one more of these. I'm going to do one of the ones where we have g composed with h of x. So right, this is like a general formula for the composition as opposed to like for a specific input value. So here I'm going to end up with an equation versus here I ended up with a number. So rewriting this one, I would get g of h of x, like that, right? And now I want to look up above and say, what is h of x? H of x is this 3 minus 4x. So I'm going to replace the h of x there with 3 minus 4x. And I would get g, parentheses, 3 minus 4x. Well, what does that mean? That means now I'm replacing the x in g of x, this x, with 3 minus 4x. So let's see what that looks like. So that looks like I'm going to write it as 3 parentheses minus 2. So if we think about, if you compare this structure right here to the equation 3x minus 2, I left this like parentheses with a blank spot where the x was in the original. And what am I going to put in that spot? I'm going to put the 3 minus 4x. So now I have this new equation that's 3 times 3 minus 4x minus 2. And that would be the composition of g and h. Now, I'm always looking to simplify, and in this case I can. So I'm going to distribute the 3. And then I get 9 minus 12x minus 2. And from there, I would just combine like terms of 9 and negative 2. That's positive 7. Just kind of rearranging my terms, I get negative 12x plus 7. So now I know g composed with h of x should equal negative 12x plus 7. So I'm going to leave 15 and 17 for you guys to try on your own. I'm just going to do one more, which will be number 18. It says F composed with G of 36. So again, understanding this notation, this means F of G of 36. So first, I'm going to start, you start on the inside, right? So I'm going to first find G of 36. So on this table, for G, I look at 36 and I see the output of 6. So I know this is now, since G of 36 is equal to 6, I'm just replacing it with 6. So this becomes F of 6. Now I need to go over to the table and say, what is F of 6? Well, when X is 6, F of X is 21. So I know that my final answer here should be 21. Okay. So do the best that you can on these. Well, let's do one final one, which will be a graph one from down here. We'll do this very last one. So 22, we get H composed with F of 3. So that's H of F of 3. So first, if I find F of 3 on my graph, go over to where X is 3. And then I have to trace down to the F of X function, which is down here. So on this is the point 3, negative 4. So that means that F of 3 is negative 4. So coming up here, I'm going to get H of negative 4 because I replaced F of 3 with negative 4. Now I need to find, now I have this new input value of negative 4 that I have to map. See what is H when X is negative 4. So I'm going to go over to negative 4 and trace up to the graph of H, and I see it's at the point negative 4, 5. So now I know H of negative 4 is equal to 5. Okay, so we will definitely be continuing to practice this in class. Do the best you can to finish the packet and come to class with any questions you may have.